Okay, so let's talk about the unit circle. Okay, 3.3. The unit circle is the circle centered at 0, 0 with radius 1. And consequently, since the radius is 1, so we recall that sine theta is y over r. That's just by definition. Well, if r is 1, then that means sine theta is just y. And in a similar way, cosine theta would just be x. So any point on the unit circle, xy, the x-coordinate gives you the value for cosine of the corresponding angle, and the y value gives you sine of the sine value for the corresponding angle. So for example, if you know that the point 1/2 root 3 over 2 is on the unit circle, and theta is the angle corresponding to that point, then sine theta is root 3 over 2, and cosine theta is 1/2. So the unit circle is a really useful way to sort of memorize some trig function values. So let me show you. I'm going to post this unit circle with this lecture so that you can kind of print this off and sort of have it with you. But this is the unit circle, and these are some of the common points that are on the unit circle and their corresponding angles, right? So 30 degrees equals pi over 6 radians, and the point on the unit circle that corresponds to that angle is the point root 3 over 2 comma 1/2. And so what that tells you is that sine of 30 degrees is 1/2. Cosine 30 degrees is root 3 over 2, right? Sine of 3 pi over 4 is root 2 over 2. Cosine of what did I say? Sine of 3 pi over 4 is root 2 over 2. Cosine of 3 pi over 4 is negative root 2 over 2, right? And so forth. And this is how you read the unit circle. You should practice reproducing the unit circle from memory. Sorry, it does this when I record. But anyway, so you should try to reproduce this unit circle from memory. It would be a good exercise to help you memorize it. And let me just show you how I do that. I mean, I don't know if I I don't have any special tricks necessarily for memorizing it, but let's say that we have our unit circle. I'm trying my best to get it sort of centered. Anyway, that'll have to do. But so we've got our unit circle. Obviously, this is the point 1, 0. You can get all the quadrantal ones pretty easily, right? This is the point 0, 1. This is the point negative 1, 0, and this is the point 0, negative 1. Okay, so you've got those 4 points. Now, in addition to that, there are 3 special points that kind of fall at 30 degrees, 45 degrees, and 60 degrees. Something like that. And so the way that it works is that I know that all of those values, they're all either root 3 over 2, root 2 over 2, or root 1 over 2. But square root of 1 is just 1, so that's 1/2, right? So it goes like 3, 2, 1. And if you think about what the x-coordinate should be at this point, it should be the biggest of those 3, right? So it should be, the x-coordinate here should be root 3 over 2. Which means the x-coordinate here is going to be root 2 over 2, and the x-coordinate here is going to be root 1 over 2. But root 1 is just 1, so I don't need to write the square root around it. So once I have the x-coordinates, then I can come back in and put the y-coordinates in, because the y-coordinates just go backwards, right? So this is 1/2, root 2 over 2, and root 3 over 2. So if you can just remember 3, 2, 1, right? Well, really, root 3, root 2, root 1, then you've got the points memorized, right? That's really all it takes. That and a little bit of common sense, and you should be able to get it. And then, of course, the other thing you have to memorize is what these angles are, right? So this is obviously the angle, well, not obviously, but you should have it memorized at this point that this is the angle 30 degrees. And I also asked you to memorize the corresponding radians. So for 30 degrees, that's pi over 6 radians. This one's 45 degrees, and that's pi over 4 radians. And this one is 60 degrees, and that's pi over 3 radians. Okay, so that takes care of quadrant 1 of the unit circle. Now the other 3 quadrants, you can get them pretty easily just by symmetry. Okay, so in other words, these 3 points over here, they're going to have the same coordinates as the ones in quadrant 1, except for obviously over here in quadrant 2 the x coordinates are going to be negative, right? So this one is going to be negative 1/2 root 3 over 2. This one is going to be negative root 2 over 2 root 2 over 2. This one's going to be negative root 3 over 2 1/2. Okay. And then as far as the angles are concerned, they're also kind of symmetric in some sense. It's like this angle here, this first angle, is going to have a reference angle of 60 degrees. So you know that it's going to be 180 degrees minus 60 degrees, that's 120. So it's 120 degrees. I'll do it like this, 120 degrees. And that would be pi minus pi over 3. So 3 pi over 3 minus pi over 3 is 2 pi over 3, right? 2 pi over 3 right here. Okay? And so forth. So this next one is 135 degrees, and it's 3 pi over 4 radians. And this last one is 150 degrees, and that's 5 pi over 6 radians. Okay? And so forth, right? So you can fill in the rest. I'm not going to necessarily finish it all for you, but you can kind of do it in similar ways. It's like down here in quadrant 3, both the x and y coordinates are going to be negative, so you know that this one is negative root 3 over 2, negative 1/2. And you can continue on down that way. This would be 30 degrees more than 180, so it would be 210 degrees. And it would be pi over 6 radians more than pi radians, so 7 pi over 6 radians, right? And so forth, right? So you can kind of work your way around the unit circle that way. So basically, once you have quadrant 1 memorized, the rest of it falls into place. And memorizing quadrant 1 is really just a matter of remembering root 3, root 2, root 1, and just a little bit of common sense, right? And then, of course, the angles, 30 degrees, pi over 6, etc. So you should memorize this. You should practice reproducing the unit circle from memory, okay? So commit it to memory. In the meantime, we're going to go ahead and use the unit circle to calculate the values of certain to calculate certain trig function values. So I'm going to use this to calculate certain trig function values. So let's do this. Let's find each function value. So let's find each function value, and I'm just going to list a bunch of these, and I'll let you pause the video and work on them to see if you can figure them out. It shouldn't be too hard if you have the unit circle there sitting in front of you. Okay, let's do cosine 3 pi over 4, sine of 3 pi over 4. Let's do cosine of negative 7 pi over 6. We'll do sine of negative 7 pi over 6. Let's do tangent of 5 pi over 3. We'll do sine of 3 pi over 2. Cosine of 3 pi over 2. And tangent of 3 pi over 2. Okay, so go ahead and give the video a pause, see if you can figure out all of those function values. Okay, so here's my solution. Cosine of 3 pi over 4, right? 3 pi over 4 is right here. Cosine is going to be the x-coordinate, so that's negative root 2 over 2. Okay, so not too bad. Sine of 3 pi over 4 is going to be the y-coordinate, so that's a positive root 2 over 2. What about cosine of negative 7 pi over 6? Well, that would be negative pi. Remember, we're going to move in the clockwise direction from the positive x-axis, so because it's a negative angle. So negative pi puts us here. That's negative 6 pi over 6. So negative 7 pi over 6 would put us at this point right there. All right. And so if we want cosine, the cosine of the angle corresponding to that point right there, it would be the x-coordinate, negative root 3 over 2. And sine is going to be 1/2. Okay, tangent of 5 pi over 3. Okay, well, so I didn't quite finish this unit circle, but I know that pi over 3 is here, 2 pi over 3, 3 pi over 3 would put me there, 4 pi over 3 would put me there, and then 5 pi over 3 should be right here. So this is 5 pi over 3. Well, maybe I'll put it here. 5 pi over 3 should be right there. Now, what are the values that should go here? Well, the x-coordinate is pretty short, so I'm thinking it's going to be 1/2. The y-coordinate should be negative root 3 over 2. Okay, so then I can figure out tangent of 5 pi over 3 pretty easily, because tangent is just sine over cosine, right? Y over x. So tangent of 5 pi over 3 is going to be negative root 3 over 2 over 1/2. Or in other words, negative root 3. Okay? Sine 3 pi over 2, here's pi over 2, pi, 3 pi over 2 is down here. So sine of 3 pi over 2 is the y-coordinate, that's negative 1. Cosine 3 pi over 2 is the x-coordinate, that's 0. Tangent 3 pi over 2 is sine over cosine, that's undefined. Okay. So that's how we do trig function values on the unit circle. Okay. Another thing that we can talk about in this section is using our calculators. Make sure you got to make sure your calculator is in radian mode because we're dealing in radians now. But let's use a calculator to approximate the following. Let's do cosine of 1.85, and I just want to show you, you've got to be in radian mode. So everyone's calculator is going to work a little different, right? My calculator is in degree mode right now, so I've got to change the mode on it. Actually, let me just show you. So I've got to change the mode on it. So I have a little button that says mode, and then I have all of these kind of complicated things, but down here where it says angle, I'm going to change from degree to radian. Now, chances are your calculator is very different from mine, so just what you can do is look at the model, look at your calculator model, and then just do a Google search, right? Say, like, type in your calculator model name and then say how to change from degree to radian mode or something like that. And somebody's posted a video somewhere. I'm positive that somebody will have instructions for how to change your calculator from degree to radian mode. Okay? Anyway, so make sure that you're in radian mode, and then of course this just works the same way as it usually does. Cosine 1.85 is about, well, since we have 3 sig figs here, we'll say negative 0.276. Okay, so go ahead and pause the video and see if you can do secant of negative 2.9234. Okay, so you probably don't have a secant button on your calculator, so you probably have to do the reciprocal identity and call this 1 over cosine of negative 2.9234. And if you do, that should come out to about, we have 1, 2, 3, 4, 5, 6 figs, so we'll say negative 1.0243 approximately is what you should get on that one. Okay? So that's how your calculator works. Just make sure you're in degree mode. We can also work backwards. So let's find the exact value of S if, and we've done these kinds of things before, but just to refresh our memory, let's find the exact value of S if sine S equals 1/2 and S is in the interval 0 to pi over 2. So once again, we can use the unit circle for this. We know that if S is between 0 and pi over 2, that puts S in quadrant 1. So we're here in quadrant 1 somewhere of the unit circle. Moreover, sine S is 1/2. In other words, the y-coordinate, right? Sine corresponds to your y-coordinates. So the y-coordinate is 1/2. That takes place here. So S would be pi over 6. Okay, pi over 6. So there's really not much work to show there, right? We would just say S equals pi over 6. Okay, but let's say that, again, sine S is 1/2, but this time S is between pi over 2 and pi. So go ahead and give the video a pause, see if you can figure out what S should be in this case. Okay, here we go. S is between pi over 2 and pi. That puts you in quadrant 2, right? Pi over 2 and pi. So, but sine S is again 1/2. That's the y-coordinate. So the y-coordinate is 1/2 right here at 5 pi over 6, right? So S should equal 5 pi over 6. Okay. So of course we can do this on the calculator as well, so that we can do values that we don't have memorized or that are not on the unit circle. But just be careful. So when using a calculator for problems like that last example we just did, note that the sine inverse, cosine inverse, and tangent inverse buttons do not represent true reciprocals. Well, they do not represent reciprocals at all. Actually, they're inverse keys. Right, so they help us do things like example 3, and we've used those inverse keys in the past. But these keys only return one value, even though there are infinitely many answers. So for example, sine inverse of 1/2, the calculator will return pi over 6. Or if you don't have a very nice calculator, it will return some kind of decimal number like 0.52, whatever. But there are actually infinitely many angles such that sine S equals 1/2, right? We just saw in the previous example 5 pi over 6 would do the trick as well. So 13 pi over 6, 17 pi over 6, and so forth, right? These are all solutions. So there are infinitely many, but the sine inverse key is only going to return one value. The reason for that is because the ranges of the inverse trig functions are restricted. So sine x is only going to return values between negative pi over 2 and pi over 2. Cosine inverse is only going to return values between 0 and pi. And tangent inverse is only going to return values between negative pi over 2 and pi over 2. We'll talk more about this in the future, although we have talked about it a little bit in the past. But just as a reminder, right, this is how the inverse buttons work. So they're only going to give you one value. Which means that sometimes we have to do a little bit of fixing up if it's not giving us the value that we're looking for. So let me walk you through a couple examples of what I'm talking about. Although again, none of this is really new. But let's approximate the value of S if cosine S equals 0.73 and S is in the interval from 0 to pi over 2. So remember, the cosine inverse button is going to return values between 0 and pi. And since S is between 0 and pi over 2, that's good. We can just take cosine inverse of this function and we should be fine, right? So S is going to be cosine inverse of 0.73. Just make sure you're in radian mode on your calculator. Cosine inverse of 0.73 is approximately 0.7. We had 2 sig figs, so we'll go 2 sig figs here. It's about 0.75. Okay? But let's say that cosine S equals 0.73, but that S now is between 3 pi over 2 and 2 pi. Right? So now what? If we take cosine inverse, we're going to get 0.75, but that's no good because we need to be inside of this interval, right? 3 pi over 2 is about how much? 3 pi divided by 2 is about 4.7, and 2 pi is like 6.28, so we need to be between like 4.7 and 6.28. 0.75 is way too small. So this is where we use our knowledge of reference angles and our knowledge of how trig functions behave. Right? If cosine S is 0.73, in particular it's positive, right? So we know that one place that cosine is positive is in quadrant 1, but the other place that cosine is positive is in quadrant 4. And so we know that S is somewhere down here in quadrant 4. And we know that the reference angle, right? So this is really the angle we're looking for, right? This is S, but the reference angle we know is cosine inverse of 0.73, right? So S should be 360 degrees minus cosine inverse of 0.73. Well, let's not work with degrees though. It's going to be 2 pi radians minus cosine inverse of 0.73. So let's see how much that is. I'm going to go ahead and plug that into my calculator. So 2 pi minus cosine inverse 0.73. Alright, so that's about 5.5 if we round to 2 sig figs. Okay, so S is about 5.5 in that case. Okay, so that's how that works. Now just be careful. You're not always going to be subtracting by 2 pi. So let's do like sine S equals negative 0.3 and S is between pi and 3 pi over 2. Okay? So remember the sine inverse button is going to return a value between negative pi over 2 and pi over 2. In this case, I can tell you that it's definitely going to send us to negative value since sine is negative, right? Since they're saying sine S is a negative number. So it's going to tell us that S is some negative angle. But we don't want S to be a negative angle. We want S to be over here in quadrant 3 somewhere. Okay? So, sine inverse of negative 0.3 is going to be like this angle down here. Right? That's going to be sine inverse of negative 0.3. Right? That's that angle. But we're not interested in that angle. We're interested in this angle. We want S. Okay. So how are we going to get it? Well, we know that this angle right here should be the same as this angle right there. Only it should be positive, right? So whatever angle they give us, whatever negative angle they give us, we're just going to make it positive, and then we're going to say S equals 180 degrees plus that angle. So here's how I'm going to write it down. I'm going to say S is going to be pi radians, that's 180 degrees, plus the absolute value of sine inverse of negative 0.3. Okay, so that's really what it's going to be. So let's see what we get. So first of all, sine inverse of negative 0.3 is that number. And so I'm going to do pi plus that number plus the absolute value of that number. So if I subtract it, actually, I'll have a double negative. That'll make it positive. So I'm just going to go ahead and subtract it and see what I get. So 3.4. Okay, so about 3.4. Okay, so that's how that works. And that's all I have to say about the unit circle for now.